Hello students, in this video we are going to discuss 6.1 and 6.2 from electromagnetic induction. Predict the direction of induced current in the situations described by the following figures 6.15a to F. If you observe A, so there is a coil and a bar magnet. The bar magnet is moving towards the coil and its south pole is towards the coil. So then automatically, so in this phase, south polarity will be formed as per Lenz law. As the S pole of the magnet approaches the coil by Lenz law, the induced current in the coil develops S pole at the end Q. For this, the induced current should flow clockwise when seen from the magnet side. Hence, the induced current flows along QR PQ. So, the direction is along QR PQ. So, this is the answer. Coming to B. Here there are two coils and the bar magnet is moving as shown in the figure. So, the south pole is approaching the first coil and north pole is moving away from the second coil. So, definitely here south polarity will be formed. Here also south polarity will be formed. As the magnet is moved, its S pole moves towards PQ coil and its north pole moves away from XY coil. By Lenz law, the induced current should develop N pole at the end and S pole at the end X. For this, the current in the two coils should flow clockwise when seen from the magnet side. Hence, the induced current flows along PRQ in one coil and along YZX in the other coil. So, for this one, along PRQ, here along YZX. Coming to C. As the circuit of the left loop is completed, the current flows in the direction of the arrows as shown in figure. This current develops south polarity on the side of the right loop. So, the induced current should flow in clockwise sense whenever we are seeing from the left in the right loop, so that to oppose growth of the current in the left loop. Hence, the induced current flow along YZX. YZX like this. Coming to D. Here, as the rheostat is adjusted or changed, the resistance decreases and the current increases. This increase the flux through neighboring coil. By Lenz rule, increase of flux should be opposed. The induced current should produce the flux in the opposite direction of original flux. Hence, the induced current flows along Z, Y, X. Along Z, Y, X. Coming to E. As the circuit breaks, here it is set released, the flux decreases, the induced current should flow along X or Y to supplement the flux. The answer is along X or Y. The current I decreasing at a steady rate. So the circular field lines set up around the current carrying wire lie in the plane of the loop as shown. The flux threading the coil in the perpendicular direction is 0. Any change in current will not change this flux. Hence, no induced current is set up in the coil. So, the answer is no induced current. Coming to (6.2). Use Lenz law to determine the direction of induced current in the situations described by figure 6.16. A wire of irregular shape turning into circular shape, a circular loop being deformed into a narrow straight wire. If you observe the first diagram A, the irregular shape turning into circular shape, that means the area within the magnetic field is increasing. So it is increasing in the direction of arrow marks. As the loop changes from irregular to circular shape, its area increases. Hence the magnetic flux linked with it increases. According to Lenz law, the induced current should produce magnetic flux in the opposite direction of original flux. For this, induced current should flow in the anti-clockwise direction, that is along AD CB. The answer is along ADCB. Otherwise here anti-clockwise direction. If we come to B, as the circular loop is transformed into a narrow wire, its area decreasing. So arrow marks are shown compressing this. The magnetic flux linked with it also decreases. By Lenz law, the induced current should produce the flux in the direction of original flux. For this, the induced current should flow in the anti-clockwise direction. That means along A dash, D dash, C dash, B dash. That means it should flow like this. Okay. So this is 6.2. So these two questions are conceptual So we should take care. Why means these are 2D. There may be some confusions. Thank you.